Okay, alright, so welcome back to our second video on section 6.4 Existential Generalization. In the last video we went over the rule itself and motivated it. So now let's put it into practice with some actual problems. Here you have an argument, it is syntactically valid, and you're supposed to demonstrate that it's syntactically valid. So if you can, and remember you got to combine these rules as we learn more of them for effect, okay? So pause now, give this one a try, and we'll come back and do it together. Okay, hopefully you were able to get it. I left these blank just so that you could fill them in case you weren't able to get it. But yeah, this is pretty simple, right? So all we did here was we universally instantiated line 1, and we went to a individual constant, which is permissible. We also could have gone to a pseudonym, either universal or existential. So this could be a U, this could be a V, it could be a B. Could be anything in this particular case, and we would still be able to existentially generalize on it and get our proof done this way. And so that's a really simple way of doing it. Everything is F, therefore at least one thing is F, and since the empty domain is precluded, that is absolutely legitimate for us. Okay, so let's look at another one. This one more complex. You start with a premise. It's got 3 universal quantifiers, and you're supposed to end with a conclusion that has just 1 universal quantifier, 2 existential, and they're in a funky order, right? So instead of x, y, z, you got y, x, z. Yeah, so if you feel like you can finish this, go ahead and do it. For those of you for whom are sort of like, whoa, wait, I'm not really sure what to do here, I want to call your attention to a little bit of a strategy we can use on this. So let's reverse engineer the conclusion. And in particular, what I want you to think about here is I want you to think about, okay, you're going to strip all the quantifiers off of the conclusion here. So this is just scratch work. If this is the conclusion and you were to instantiate, right, let's say that y was going to be b. Let's see that x was going to be, it's going to have to be u because we know we're going to universally instantiate, and in order to universally sort of generalize, we need a u there. And let's just say that the z is, C or something like that, or maybe even a pseudonym of some kind, okay? So maybe this is a V, maybe this is a V, but importantly, they need to be different V's because we've got 3 different variables, and that's just going to help us keep everything straight in our heads. So what I want you to do is pause now and sort of strip all the quantifiers off, reverse engineer the conclusion down to what it would look like without any of these quantifiers. Pause now. Okay, hopefully you were able to get it, but I mean, let's take a look at this. So the first thing I did was I stripped this quantifier off using existential instantiation, which although we haven't gone over intuitively, right, you're just going to, take this off, and then the y is going to become the b, and you're left with this whole thing right here once that's stripped off, right? And then you're left with this whole thing here, and you want to strip off this. But we know we need to go to a u because we want to universally generalize the thing in the middle, right, that we're looking at here, the j. So the j is going to become the u, right? And that means that after you strip this quantifier off, you're left with just this. And if you were to existentially instantiate, which we haven't gone over yet, but we will in the next video down, you'd get something like this. So the big payoff is that if we look at it like this, okay, we've got this problem. We can imagine the conclusion, instead of looking like this, as looking like this. So the idea now is quite simple. What we have to do is we have to go from our one and only premise to something that looks like this, and then we're going to universally instantiate, which we're already familiar with that rule, down to something like this, and then we're going to existentially generalize. So there's your big hint. Universally instantiate this until you end up with something like this, and then build this using existential generalization and universal generalization from this. Pause now. Okay, and hopefully you were able to get it right, but it's no big deal. So what we've got here is the deduction, and we just universally instantiated each of the universal quantifiers off systematically until we were left with something like what we were looking for. And then it was a matter of, okay, I have to build this in the correct order. If I want Z in this first position, it has to be the first one I do. And we want the Z here. Notice it shows up here in the conclusion to be on the G. So that one's going to get existentially generalized, and these other ones are going to be left alone. Then, looking at the desired conclusion, I know I need this guy in the middle, so I'm going to universally generalize, and we better make sure we have the U there, right? So if we didn't instantiate this to a U before, we better go back up there and make sure we did it. A little bit of trial and error. Say, okay, I got it. Okay, great. Now I've got this guy, and then I know that to finish it, I need this in terms of Y, so I'm going to existentially generalize sentence 6 here, and it's going to end up looking like this, and the Y needs to go on the F, so that's what we replace, and that's a QED. So I hope you're really seeing how sort of reverse engineering and paying close attention to what you're trying to get from the conclusion really sort of lights the way for how to proceed on these kinds of deductions. All right, wonderful. Let's look at a last pair of problems where the contrast between them, I think, is nice and illustrative of the rule, e.g. All right, so for this last case, what I want us to do is I want us to look at two syntactic deductions side by side. So this one we're going to do right down here, and this one we're going to do right down here, and we're really going to get a close look at this. So notice, both of these arguments have the exact same first premise, okay? But both of them have different, though similar looking conclusions, okay? So the conclusion of this one here is a conjunction. And the conclusion of this one here is a universally quantified sentence with a conjunction inside of it. And both of these are syntactically deducible, but you have to pay attention to your rules and what you're trying to build and why you're doing the things you're doing in order to prove each of these. And so the proofs are going to be slightly different. So what I want you to do now is I want you to think just about this first one right here, okay? And I want you to try to get it. And remember, when in doubt, try to reverse engineer the conclusion, and that will give you a hint as to how to proceed. So try this one now, and pause now and give it a shot. Okay, hopefully you were able to do this one. Remember, if you were to sort of reverse engineer this, you would get FU and there exists a Y such that GY. You would common sim them apart, and then you would get like GV, right? And so let's actually go ahead and take a look at that together. So looking at the desired conclusion, this is the conclusion. This is what we're trying to get to from the premise, okay? But if we just fiddle around with the conclusion for a second and see, you know, if that helps us light the way of what we should be trying to do when we screw with the premise, this conclusion, if we detach the quantifier, we end up with FU and that. And so then you can com and simp it apart in standard procedure. And then this would be existential instantiation, which we'll go over in the next video, but you would detach this quantifier. So I know that in reverse order, right, I'm trying to get a GV and an FU and or a GA and a GB, something that I can existentially generalize on, and a U on the F so that I can universally instantiate or universally generalize on it to get this sort of construction here, right? I'm trying to build something like this, basically, is the idea. And in order to build something like that, right, I'm going to need something like this, FU and GV, which you could get from, you know, conjunction here on this guy, and then I could existentially generalize that, right, to get FU and I'm just going to do this the quick way. There exists a Y such that GY, right? And now I'm kind of really slowly building this thing together, and then when I universally instantiate that, I'm going to get this out of it. So that gives me a real hint, right, about what I'm trying to do. So if we go back up here and look at the solution, right, you'll see that a lot of these kinds of things occurred. So, you know, this was already a B from the premise. That's really nice. So I can just leave that, right, universally instantiate this, and I get down to this guy, right? But I need to get that, GB existentially generalized, but existential generalization is a rule of inference, not replacement. So I can't go inside this sentence and just do it right there. I've got to pull it apart, then existentially generalize it, then start stringing it back together until I've built the thing that I'm looking for, okay? And that's why it's done this way, okay? Because you're following all these details of the rule existential generalization. Now, let's go ahead and contrast that case with this case, all right? And again, you might think about sort of a reverse engineering the conclusion to give yourself a clue as to how to proceed, but go ahead and give this one a try, and we'll come back and do it together. Pause now. All right, hopefully you were able to get it, and if you started by reverse engineering these, you probably would have calmed and symmed them apart. So you had this by itself on a line, and you had this by itself on a line, and then you had like an FV and an FV1 or a GV1, right, that you existentially instantiated or whatever, okay? So looking at the premise that we're given, right, we universally instantiate it, and I don't need to worry about universally instantiating to a U because I'm only going to be existentially instantiating. You could go to the U, but, I want to keep these things separate. I want a Y, so I'm going to make that the B, and conveniently it already is the B, and I'm going to make my X here the A. So I did that, and then I have to pull them apart. I can't just start applying existential generalization inside here. It's a rule of inference, has to apply to an entire line, right? You're attaching the existential quantifier to an entire line. So I got to pull them apart and do them separately, right? And that's the big key difference between the two deductions, right? And that's why they have a different procedure. And then I can join them together so that I end up with this conjunction here rather than with a universally quantified statement here. And that's basically the ins and outs of existential generalization. There's plenty of practice problems in the book, so make sure you're looking at those, and we'll see you on the next video, Logic fans.